Hello guys, I'm going to be showing you a review of some topics in pre-calc for students that will be beginning calc soon. So I'm going to start off with some questions that ask you to find the domain, range, and graph of the function. Note that the graphs are already shown on the right, but I'll just be explaining how you get those graphs just so we could keep this video from being too long. So this first question asks us to find the domain and range of this function y equals ln of x minus 3 plus 1. So to find the domain, we just have to see where this function would not be defined, and we know that you have to know that inside the natural log function, it cannot be equal. It cannot be negative or 0. So to do this, we'll just set that inside greater than 0, and then we know that x is going to be greater than 3. So that's the domain. So in interval notation, this would be the interval from 3 to infinity. Not inclusive at 3 because it's not defined at 0. That would be the natural log of negative infinity, which would not be a defined value. And now for the range, we're gonna see where this would be defined. So we know the natural log function is defined from negative infinity to infinity, and you should just know what the natural log function looks like. That the natural log function normally looks like this. It's an inverse of the e function, and to see to get this graph here that's on the right, we have to know what the normal function is going to look like, and then we're going to see that it's x minus 3, which would indicate a shift of 3 units to the right. You do that by setting x minus 3 equal to 0 and adding 3 to both sides, and that's going to be move 3 units right, and then plus 1, so 1 unit up, and that gets this graph here on the right. Okay, for the second one, we'll try to find the domain. So we have to see where this function not be defined. Well, here we have a cube root, and inside cube roots, that everything is defined, both positive and negative. So there's nothing here that won't be defined. So actually, the domain of this function is going from negative infinity to infinity. And now for the range. Well, let's just think, what does a normal cube root function look like, disregarding these shifts left and right? Well, we know that they look like this normally. They normally look something like that. So that would be defined from negative infinity to infinity as well. And how to graph it. So knowing that the normal cube root function looks like that, we're going to move it 1 unit down, and then set 2 minus x equal to 0 to get that it's going to be moved 2 units to the right. So it just shifted 1 unit down and 2 to the right, and that's how you graph it. Okay, so for this number 32, there's a couple ways you could think about this one. So let's start off with getting the domain. So the first thing is you want to see where this is defined, right? Well, we know that tangent normally isn't defined at pi over 2 because tangent equal to sine over cosine, and we know that the cosine of pi over 2 is equal to 0, and that you can't divide by anything by 0. So that's going to be undefined. But let's try to simplify this a little more. So we have tangent of 2x minus pi. And a trick is that this is just going to equal to the same thing as tan 2x. And you can know this because that minus pi is going to indicate a shift of this function 1 pi units to the right. Or actually, wait. Pi over 2, my bad. 2x minus pi, you said equal to 0. And it's equal to x equal to pi over 2, right? But this actually isn't going to make a difference because the period of the tangent function is pi. So moving it pi over to the right isn't going to change it. So that shows that it's just going to be equal to 2x. Sorry. Because you could see that as I drew on that graph on the right, the asymptotes, it would just move in the same way, not changing the function at all. And another way that you could do this is you could use the identity of for tangent of a minus b and plug in 2x minus pi, and that'll go to 2x. I'm not going to do this here, but that's just another way to show that this is going to be equal to the tangent of 2x. So So we know that the function is equal to tangent of 2x, and we want to see where it's not defined. Well, it's not going to be defined when tangent of 2x is equal to pi over 2. I mean, just when 2x is equal to pi over 2. So we can divide both sides by 2, and x is going to equal to pi over 4. But it's not just pi over 4, it's going to be any multiple of pi over 4. So it's not defined when x is equal to pi n over 4. That's where it's not going to be defined. It's going to be defined everywhere but there, at multiples of pi over 4. And now for the range of the function. The range of the function, you should just know this, of tangent is going to be from negative infinity to infinity. And you could tell by just looking at the graph also. Okay, so we have a piecewise function here for number 38. While starting calculus, you should remember how to graph these piecewise functions. You just graph the indicated function that it gives over the given interval for each interval that it gives. So I saved us some time here by graphing on the right, and to get the range and domain, we could just look at it. So I'm just going to write domain. Wait, my bad. This one is the domain, and this one's the range. Okay, so for this next one, let's find the domain. So where is it defined for x? Well, it's defined from negative 2 to 2, inclusive. And where is it defined on the range? From negative 1 to 1, inclusive. And you can just look at the graph for that one. Just graphing the piecewise function. Okay, for number 63. It says a drug is administered intravenously for pain. The function is given for the number of units in the drug in the body after a certain amount of time. And it's asking for the initial number of units of the drug administered. So that's just going to be the initial value of this function, or f of 0, where it's first defined. And it gives that it's defined from 0 to 4. So it's just going to be at 0 hours. So just f of 0. And I'll plug this into my calculator to get it. ln of 1 plus t. Okay, so then the first value is going to be 90 units. That's the initial value. It's pretty easy, just a plug-in, and a calculator is allowed on this question. A calculator would not be allowed on those other questions. And then the next one asked how much is present after 2 hours, such as the function evaluated at 2. And that's going to be 32.87 units. And a graph of the function, a calculator is allowed on this question, so you could just graph it on your calculator. And it's going to start off with a y-intercept of 90, because 90 is the initial value, and then it's going to decrease from there. And that's a review of some pre-calc questions for students who will be beginning calculus soon.